thermal imaging camera, commonly known as the TIC, been used in the fire and rescue service for over 30 years. Greatly enhanced the capabilities of the emergency services in that they give us greater capability in our search and rescue operations. So it can be used to see through smoke and partially lit or dark areas to detect heated objects. Also any heated atmospheres. They can pick up heat signatures in darkness. Bushfires, like when blacking out, detecting hot spots or any smouldering. In confined space applications. Can be used in road crash rescue, ring of hotspots in the vehicle, and also detecting the heat signatures of people that may be laying in dark or hard to see areas. So they can be utilised for water rescue, search and rescue application, looking for hotspots in walls and ceiling spaces, seeing through smoke and heated atmospheres. They're portable, easy to use. Matt Tinker will be going through the uses and characteristics of the thermal imaging cameras, as there are several types used throughout the business.
Interpreting the image on your thermal image camera will vary depending upon manufacturer. On this camera, you can see the temperature on the right hand side represented by a colour. Black being coldest, dark red being hottest. On the left hand side, you will see which mode the camera is in. The mode will be determined by the variation of temperature within the field of vision on the camera. At the moment, we can see that this camera is in high sensitivity mode. As we change the temperatures within its field of vision, you'll see the camera now change to a medium sensitivity mode, which changes what the colours on the right hand side represent. As we move into more hotter objects being in the field of vision, we'll see the camera move into low sensitivity mode, and then on the right hand side the temperatures will change. Moving back into medium sensitivity mode, we'll see those temperatures change back again, and then back into high sensitivity mode, those temperatures have changed back once again. Water is a poor conductor of infrared radiation and will prevent that wavelength from passing through it. Note how the hand on the thermal image camera disappears once we immerse it in water. Understanding the range of temperature within the field of vision of the camera will help you better understand the contrast shown on the image of the camera. In this example, the camera is in low sensitivity mode and is pointed at the hottest object within its field of vision. This can lead to comparatively cooler objects being missed while doing a search. The emissivity of a material is its effectiveness at releasing energy as thermal radiation and is a key concept in thermal imaging. Shiny surfaces are poor emitters of thermal energy. Notice how the image on the thermal image camera is reflected off this shiny surface. The temperature of the surface we are looking at has not changed, but the thermal image camera is interpreting a change in temperature due to the reflection on a shiny surface. Here we have two mugs, both filled with boiling water. The contents of the mugs is the same temperature. The mug on the left-hand side has a good emitter of thermal energy. The mug on the right-hand side has a poor emitter of thermal energy. When we look at through the thermal image camera, notice how the ceramic mug gives us a true indicator as to the surface temperature of the mug. The aluminium mug with a shiny surface does not give us a true indication as to the surface temperature of that material. If we move up to where the red electrical tape is, notice how the temperature changes on this thermal image camera. This is because the electrical tape is a good conductor of thermal energy. Look now at the surface of the bench top. It being a reasonably shiny surface is also reflecting the image from our hot mug, and you'll see how the temperature changes the temperature of the countertop changes based on where we are pointing our camera. Not all manufacturers of cameras will show the same image. Notice the temperature range and the associated colours on the right hand side. As we move over to a hotter object, this camera moves into a lower sensitivity mode, changing what the colours represent on that scale on the right hand side. Then again moving back, infrared light does not pass through glass. Notice how the glasses block the image on the thermal image camera. In this situation, we can clearly see the toaster through the window. However, if we look through the thermal image camera, we will only see the image which is being reflected off of the window. Stop. Awesome. Yep, turn it off.
So the best way to get familiar with your thermal imaging cameras is to just get it out and give it a go.